Hello class. Today we're going to talk about finding distance between 2 points. In our lesson today we are going to first talk about some key definitions that are very important for you to understand in order to succeed in this lesson. Next we're going to talk about distance on a number line and then distance on a Cartesian plane. Lastly, I'm going to give you some practice so that you can be prepared for tomorrow's class. Let's start off with the key definitions. The Pythagorean theorem. The Pythagorean theorem states that for a right triangle with sides A and B and a hypotenuse C, that the lengths of each side when squared and added together equal the hypotenuse squared. So A squared plus B squared is equal to C squared. I also am going to talk about a point of reference. It is defined as an indicator that orients you generally. Sometimes we're going to be given word problems where we are not oriented to where the points are on a number line or in the Cartesian plane, and we're going to have to find a point of reference that's going to help us plot those points and ultimately find the distance between them. Let's talk about distance on a number line. So here is a strategy to find the distance between 2 points on a number line. First, we need to identify the points in question. So as I spoke about before, we're going to need to identify a point of reference so that we can place those points accurately. Sometimes this will not be an issue if we're given the points, but if we have to go through a word problem and find those points out of the wall of text, we're going to need a point of reference. Next, once we have these points, we need to identify the position of the points on the number line. Third, we subtract the smaller value from the larger value, and then the resulting number will be the distance between these 2 points. When I mean a larger value, I mean a more positive value. If I have 2 points, -10 and -4, -4 is the larger value because it is more positive. Let's go to an example. If I have points -6 and 4, identifying these points is pretty easy. I have given them to you. So next, let's place them on the number line. Then we subtract the smaller from the larger. So we subtract -6 from 4, and we get the result of 10. So the distance between these 2 points is 10 units. I have units there right now because I need to call them something, but I don't have a problem to reference from where to get these units or what 10 represents right now. Let's try an example now that we actually have units and we also need to translate and find a point of reference to be successful. I am 5 miles directly behind my house, and my brother is 9 miles directly in front of my house. How far away from my brother am I? First, we need to find a point of reference. That is something that is similar to both my distance and my brother's distance, and I see in the problem that the house is a point of reference for both me and my brother. So if I place the house at point 0, I can place myself at -5, so directly behind the house, -5, and my brother at 9 ahead of the house. So I place those points, and now I can subtract the smaller value from the larger value, subtract -5 from 9, and I get 14. So the result is 14 miles lie between my brother and I. Let's move on now to the Cartesian plane. Now you may wonder, does the same strategy work for the Cartesian plane as it did in the number line? No, it doesn't, because we now have 2 dimensions to worry about. Not just an x, but also a y now. So here's the following strategy that you should use to be successful in solving these problems. Again, we need to identify the points in question, and this may also need a point of reference for us to plot these points. We need to then graph the points, create a right triangle using the line connecting the 2 points as the hypotenuse. So I have 2 points, I connect those 2 points with a line, and then create a right triangle off of that line, using that line as the hypotenuse. Then identify the lengths of the sides of the created right triangle and use the Pythagorean theorem to find the length of the hypotenuse. And then our resulting length will be the distance between the 2 points in question. So let's try an example. I have points 1, 1 and 5, 6. So identifying these will be pretty easy. I have given them to you. So let's plot those points. 1, 1 and 5, 6. Now I need to create my right triangle. So I need to extend downward a segment from 5, 6 and extend a segment positively in the x coordinate way from 1, 1 a segment. They will meet at 5, 1, and so I have a point there and my right triangle is created. I then need to identify the lengths of the two sides. So for my x-axis, as it looks in this picture, the base, I need to subtract the second x value from the first x value in the 2 points. If you look up at my first bullet point, you'll see the second x value to be 5 and the first to be 1. 5 minus 1 is 4, and so the distance of the base in this example is 4. And then the height, I do the same thing now with the y values, and I get 5. So I'm left in question, the distance between my 2 points is now d. By the Pythagorean theorem, I can say that the sides, when added together, squared and then added together, is equal to the square of my third side. With simplification, I have d is equal to the square root of 41. If I add 4 squared and 5 squared together, I get 41, and then the square root of both sides will give me the square root of 41. It is important to note that there cannot be a negative answer here because we're talking about distance. And so that is that is the answer, is the square root of 41 units again. Pause the video quickly to copy these notes down, or copy these questions down that I want you to complete for class. Thank you again for listening to me, and good luck. I look forward to seeing you in class tomorrow.